Good evening. We're about to start talking about exponents. Exponents is a really big idea in algebra, and you use them a lot. So we want to get familiar with just some of the basics today. So you've got your handout number 10 in front of you now. Let's just take a look at some of the terminology going on. Down here I've given, this whole thing is called an exponential expression. It's exponential because it has an exponent in it, and the exponent, I can get my pencil to move here, the exponent is the 3, and we call this number here the base. Notice the exponent is tiny and raised. It's like what we call a superscript. If you get careless, you'll start making your exponents as big as your base, and it'll just look like you wrote the number 53 down. So you have to be really careful. First, I kind of jumped over this up at the top, but that term exponential expression, an expression, firstly, is just a math problem without an equal in it, like 3 plus 5. So if you throw in an exponent, we call it an exponential expression. So an exponent can also be referred to as a power, but it tells you how many times this base, so how many times 5 is being multiplied by itself. Not 5 times 3, but 5 times itself. That's very different. You have to get really good at seeing them and knowing what they represent. So I just wrote it out here. 5 cubed, or 5 to the 3rd power, or 5 to the power of 3. Those are three different ways that you can say that. But it just means 5 times 5 times 5 times 5. 5's the base, 3 is the power. Well, that bodes the question, when are we ever going to use exponential expressions? Well, we use them a lot, especially in algebra, but also otherwise. We use them to represent large numbers in a simplified form. For example, instead of writing the number 100,000, 10 times 10 times 10 times 10 times 10, 10 times itself 5 times is 100,000. The powers of 10 are very simple to write exponentially. 100 would be 10 squared. 1,000 would be 10 to the 3rd power. 10 to the 4th power would be 10,000. So the number of zeros actually indicates the power for powers of 10. Likewise, if you have really, really small numbers, you can write them using exponents. I'm still using powers of 10, but notice this 0 is in the tenths, hundredths, thousandths, 10,000ths, and the 1 is in the 100,000th place. So this decimal is 1/100,000. Well, we just talked up here how 100,000 equals 10 to the 5th. So if you rewrite that again as 10 to the 5th, to get from here to here, the way that we write it is using a negative exponent. It really just means to flip something over or take the reciprocal. Reciprocal is making what was in the denominator the numerator and what was in the numerator in the denominator. Well, if you flip it, this negative indicates reciprocal. And as I wrote over here, we're not really tackling negative exponents in the 6th grade, but you should be aware that they do happen, and there will be some enrichments that involve negative exponents. All right? All right. Well, we're back. A times A times A is A to the 3rd. Meter times meter, meter squared. We could have just used an M here. Centimeter times centimeter times centimeter is the abbreviation for centimeter cubed. And then when you get down here to the bottom, that's a little bit different directions now. Now they're saying evaluate the following. Rewrite each in expanded form first. So let's look at the ones that I've already written out here for you, and then we'll back up to the others. They're a little harder. The base is the number that's in these parentheses. When you have negative bases, it's a little different. Here the base is -2. Here the base is 2, meaning 2 is the only thing being raised to the 4th power, and the minus over here is actually meaning take the opposite after you raise 2 to the 4th power. So 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, and this minus sign just keeps coming down. Now that really messes up quite a few algebra students right there. The difference is when you put it in parentheses, then it actually means -2 times itself 4 times, which comes out to be a positive 16, because a negative times a negative is a positive. Negative times -2, positive 4. So these answers are very, very different. And typically what happens is a student means what I wrote for part C, but this is what they write on their paper. And it's important that your notation matches what you're trying to represent, because these two things could both be legitimate parts of a problem, but they come up and they're simplified very, very differently. So you got to make sure you know what you mean. Well, now we already know that 2 to the 4th, because of our work over here, we did 2 to the 4th and then just dropped down our minus. So we know that part A over here is 2 times 2. This is expanded form when we write it out, 2 times 2 times 2. And you could go directly to 16. That's kind of nice to show some little steps here. I'm going to try to write neater. I'm not writing very, oh gosh, that's a terrible box. Bear with me, kids. So when you see 10 to the 4th, based on what we've already talked about, we know that's a 1 with 4 zeros. So since the directions say to write it in expanded form, I'm going to go ahead and follow those instructions. You could also use the multiplication dot if you don't like writing so many parentheses. I'm kind of going downhill here, aren't I? So each time you have two 10s multiplied together, you have 100. So 100 times another 100. And when you multiply here, your shortcut, if you're not familiar, is multiply the 1s. And then you've got 4 zeros. So 1, 2, 3, 4. So we've got the number 10,000. This problem is in exponential form. When you write it all multiplied out, that's called expanded form. And what we've got for our answer here is actually simplified. We have simplified this exponential expression to write it as 10,000. Now this next section is a little harder. Let's just walk through what we've got here. Now we're using exponents to write the following using one power only. So we've got the number 4 times 8, which we could just say is 32, but that would not be expressing it using one power. So it works a little bit better to take the number while it's sort of broken up into two factors. We could rewrite 4 as 2 to the 2nd power, because 2 times 2 is 4. If we multiplied 4 times 1 more 2, we would get an 8. So 8 can be rewritten as 2 to the 3rd power. Well, if we expand it, these two 2's right here would be right there. And then this one, I should use a different color for that. Let me back up for a second. Let's say this one, 2 to the 3rd, that's these 3 right here. Let's circle this one in blue. So you can see that if you take these 3 plus these 2, you've got 5 2's being multiplied together. Well, that's represented 2 to the 5th. A shortcut and I wrote over here, if I think about it, I can see that I can jump all the way down here to 2 to the 5th if I just add these exponents. It's not an addition problem. Notice we're keeping the base the same, but we're adding the exponents just as a shortcut. I mean, imagine if these numbers were really large. There's no need in really writing them all out once we've sort of seen what that pattern is. So you could avoid this step in the middle, but include it for now if you want. So take a look over here at this example. 25 times 5. Well, the first thing I want to think about is what is a number that I could use as a base for both of these? Well, 5 is smaller. Oops, I need to get back to pen. So I'm thinking, well, I can rewrite 25. If you know your multiplication facts, you know 5 times 5 is 25. So we could write that as 5 squared times over here, we've just got 5, which it's understood that the exponent right here is a 1. We don't typically write it. I'm writing it now just to make it a little bit easier to see the next step. But if I wrote it out in expanded form, it would be 5 times 5 times 5, which is 5 times itself 3 times is 5 to the 3rd. If I wanted to jump from there to here, I could just look at my exponents and add. Oftentimes when this one's not written as a 1, for example, if a student is looking at it like this, whoops, they typically want to say 2 plus 0 because they don't see anything there. Well, that wouldn't make any sense because 5 to the 2nd times another 5, there's 3 5s involved. So it has to be 5 to the 3rd. So, you have to think a little bit. If you get in a hurry in math, your logic goes out the window, and then you start writing crazy stuff down. We don't want that. So let's scroll down and look at some more. I made a note here that the error on this problem, because it's a multiplication problem, students often want to multiply the exponents as well. But we've shown why that doesn't make any sense. But that's what the brain wants to do when it sees that multiplication sign. We've seen it many times. Well, let's go ahead and try this first one. When you see the 4's here, it should come to mind, oh yeah, 16 is the same as 4 to the 2nd power. So we could write 4 to the 2nd times 4. If you want to put that little 1 in, you can. You really don't want to develop a habit of writing that. It's just we're new to it right here, so I'm writing it, but this is not something that I typically would write. But we've got the same base, so we could keep the base, and we could add 2 plus 1 plus 3. And just so we'll remember when we come back to your notes what happened, where this new exponent came from, we'll go ahead and write that in. So you've got 2 4's plus 1 more 4, that's 3 4's, plus 3 more 4's, so you've got a total of 6 4's being multiplied together. Now this is one way this problem can be written. It could actually be written using a base of 2 all the way through as well, but this is actually the easiest way to rewrite this one because we didn't have to do anything to the 4 and we didn't have to do any more work on 4 to the 3rd. The directions just said to rewrite each one using one exponent. So you can only have one exponent in your problem and one base. So if you look at this one, it doesn't take too long to realize I'm pretty sure my base is going to be 2. Well, maybe we should just go ahead and multiply 2 times 2. That would be 2 to the 2nd. And we could rewrite 8 as 2. Actually, I need to raise. That looks like a decimal when you write it too low. So, don't want to be lazy. And now it doesn't even look like it. Bear with me. There we go. So this is going to be 8. So 8 would have to be 2 to the third, which we discovered before. Bring down another 2 to the third. And so you have 3 2's plus 3 more 2's plus 2 2's. So 3 plus 3 is 6, plus 2 more is 8. So you've really got 2 to the 8th power. It would be a lot harder if you just tried to multiply all these together. Remember, we're not trying to simplify. If we were, we would expand this 2 to the third and call it 8, and then just multiply all these numbers together, which wouldn't be nearly as much fun as what we're doing right now. Part E is actually one of the easier ones. Imagine this all written out in expanded form. I'm going to write it this time. There's the first one. B times another B, and B to the third, I'll write this one in a different color, is B times B times B. So if you look at all this together, you notice that you have 1, 2, 3, 4, 5 B's. So you have B to the 5th. Well, instead of writing out that whole expanded, this step right here, couldn't I just think, well, that's a 1, and that's a 1, and then add my exponents, 3, 4, 5. That's another way to get there. Just a little bit of a shortcut. Now, the following instructions are different. Again, it says rewrite the following expressions in simplified exponential form. No support is needed, but you may show it if you feel better doing it that way. When in doubt, write it out. That's actually a good suggestion right there. Well, let's see. If we just use sort of our little shortcut and imagine it all written out, we have 3 2's, and then we have 4 2's. So if you have 3 2's and then 4 2's, you'd actually have 7 2's all multiplied together. So this is simplified exponential form. If it asked for expanded form, we would actually have to multiply 2 times itself 7 times. Pause the video and write down what you think the answers are for these next two, and then we'll come back and check. Okay, well, here I got 6 to the 4th, because remember there's 3 6's plus another 6, so there's 4 6's being multiplied together. Here we have 3 here and 2 here, so that's 5 5's, and here's the 6th 5, so it's 5 to the 6th power. I should have mentioned another common mistake is sometimes students want to multiply the 5 times the 5 times the 5 and then add the powers to get like 125 to the 5th power or something silly like that. That doesn't make any sense. We're keeping the base, and again, if you start to think something like that, just reason it out and write it out, because this one, if we wrote out the steps, would be 5, and then 5 squared would be 5 times 5, and then 5 cubed would be 5 times 5 times 5. If you see it all written out like this, it's easier to see that, oh, I have 1, 2, 3, 4, 5, 6 5's. So it's 5 to the 6th power. I hope you enjoyed learning about exponents, and there is no homework for you to do after this, so you might just review the notes, just make sure that you're clear on it, and if you need some extra practice, see me.